Hundreds of millions of years ago, the supercontinents of Pangaea and Gondwana fractured, tearing along massive fault lines to form the geography we recognize today. We look at a modern globe and assume that process is finished, with the shapes of the continents printed permanently in our atlases. But at the East African Rift, the reality is visible. This massive drop-off is a reminder that the map is actively pulling apart. The Earth's map is actively tearing itself apart right now. While the East African Rift is well documented, geologists have identified a second parallel fracture, cutting diagonally across Central Africa. This map outlines the suspected boundary, the 2,500-kilometer southwestern rift. If this fracture completes, it severs the massive Nubian plate to carve out the new sand plate. This boundary has remained mostly invisible, identified by subtle ground features and low-level earthquakes. Proving a continent is splitting requires evidence that the fracture penetrates the entire crust to connect with the Earth's mantle. Surface cracks and minor quakes can be deceptive. Scientists need physical proofs from deep inside the Earth before they can officially rewrite the map. Geologists found their testing ground for this invisible plate boundary in Zambia at a site known as the Kafue Rift. Instead of drilling through miles of rock, researchers investigated the geothermal hot springs bubbling up from the suspected rift zone. They were hunting for microscopic gases escaping from the springs, specifically focusing on helium isotopes. Helium-4 is common in the crust, produced by radioactive decay of rocks, but helium-3 is primordial, trapped in the Earth's mantle since the planet's formation. Detecting helium-3 at the surface confirms a direct, deep Earth fracture reaching all the way to the mantle. These gases act as messengers, carrying the structural secrets of the lithosphere up to the surface. This chart displays results from the Kafue Rift. Samples showed unusual concentrations of helium-3 and mantle-derived carbon dioxide, matching signatures from the active East African Rift. Control samples taken 50 kilometers away showed zero mantle helium, proving the rift is uniquely fractured. This confirms the crust beneath Zambia has thinned and cracked enough to create a fluid highway straight to the mantle. The geochemical data is in. The physical breakup of Central Africa has begun. Comparing the early-stage Kafue Rift to the mature East African Rift reveals the life cycle of a tectonic split. Millions of years from now, the Zambian Rift will widen and become highly volcanic as the mantle pushes upward. Eventually, the ocean will flood into the widened valley to permanently sever the sand plate from the rest of the continent. In Zambia today, we are witnessing the starting point of an ocean's birth. This discovery has major implications in the present day, long before the map is finally redrawn. Active tectonic rifting creates massive geothermal energy potential for Central and Southern Africa. The gases bubbling up, helium and hydrogen, are valuable commercial resources trapped within this new boundary. The Earth operates as a dynamic machine,